Okay, well, you know, I kind of made a bad decision here. I decided, okay, let's just write down a simple equation and solve it. Okay? Turns out what I should have done was figure out what I wanted to use for x, maybe just a sine of pi t. But I wanted to use sine of pi t over here because we've already got the transform. Well, that saved us a little time, but no. Wasn't a good idea. Still, you know, you could get something like this. You don't know what your system's going to be. You get anything. So it could well be something this complicated. So let's just look at it. Okay, you solve the homogeneous equation. That's straightforward. You get your characteristic equation. You get your lambda. You write down your solution. Right. And what I wrote down here makes no sense at all. I wrote down the non-homogeneous system here times part of the solution of the homogeneous system. Okay? And you're going to have to write a lot of that down again. Anyhow. Okay, well, using undetermined coefficients, I assume x is b sine of square root of 3 over square. It's sine of pi t plus c times the cosine of pi t, right? Then my two derivatives and everything combined to give me this on the left-hand side, if I did everything right, okay? Then I've got an et cetera here because, of course, that's going to be equal to the sine of pi t, right? That's not sine of t, that's a sine plus, okay? I probably ought to put a couple of parentheses in there to indicate that I'm still talking about the sine of that argument, which is pi t in this case, okay? So actually I can kind of fix this. Well, when I solved for b and c, I got constants like this and this, okay? The b was this, the c was this. I don't guarantee that was correct. Matter of fact, I almost guarantee it wasn't. So you guys can fix it, okay? And then I used this along with this, which is, you know, to start writing things down without thinking. This is the non-homogeneous solution. And usually we write the homogeneous solution first, but the homogeneous solution is just this. Okay? Well, there's our x function. Now, we've already got the Laplace transform for the right-hand side. All we have to do is write out the Laplace transform for the left-hand side, which is not difficult, okay? Because we know the Laplace transforms for this and this. It gets ugly. And then we got to do the Laplace transform of this function, okay? And that's not difficult. You can integrate a sine times an exponential. And you have a formula for sine times an exponential anyhow. Okay? So we don't have time to finish this. But I'll just give you, I'm going to ask you to finish this for homework just to see if it works out, see if you can do the algebra. Make sure my algebra is correct because I did a lot of this in my head, right? Which almost guarantees that I screwed up something. But if your solution happens to match mine, and your solutions happen to match each other's, compare by email or whatever, okay? Then your solution's probably right, okay? Or if your solution matches mine, then it's probably right. Okay, if all three of us match, then we're sure we're right. And that's how a team works sometimes, okay? Although, you know, you got a weak link in the team right here. Okay, so let's try another one though. Let's, okay. If your x of t equals, let's say, not to mix it up with any of these functions, cosine of pi over 4t, then x double prime plus x prime plus x equals what? Well, x double prime is going to be a pi squared over 16, right? And x is just going to be a 1, so it's going to be okay. Now check me on this too. I think I'll get this right. Yeah, I said I've already got it wrong. It should be a negative pi squared over 16, right? Okay. And then that's the second derivative plus dx, and the first derivative is going to be plus, no, sorry, minus pi over 4 sine of pi over 4 t. Right? Now, check, make sure that's right. But you see, you can easily transform this equation, assuming that x of 0 equals x prime of 0 equals 1. Although we're not going to do that. We want to do the Laplace transform of our output function, which is this, divided by the Laplace transform of our input function, right? So we should have A, B, and C are all 1, right? Does this equal the question mark Laplace transform of our driving function, which is this? This is the signal that's driving our system. I'm sorry, this is the signal that's driving this system, and this is what comes out of it. Okay? This is much simpler. So you might even start with this one after you verify things. So it's Laplace transform of negative pi squared over 16 cosine pi over 4t minus pi over 4 see, I've already messed up because negative pi squared over 16 plus 1 times the cosine, right?
Right.
Because I'd left this off. I said it and then I didn't write it down.
Right.
Which is why you've got to watch me. Okay? So you got to Laplace transform this, but that's easy. You can write down the transform of this, and then just multiply by the right thing here. It'd be negative pi squared minus 16 quantity over 16. I'll correct that before I do the board pictures and post them. Okay. Before I do the videos. Okay? Well, on the board pictures you'll see this. Okay. And then that's over the Laplace transform of the driving function, which is cosine of pi over 4t. Right? So when you do this and do this, you should end up with reciprocal of a plus b plus c, if you get this part right. Okay? So that should be pi squared plus 16, pi squared plus 16 in the numerator here. And that's written so small you can't read it, but I'll wash that off. Write it down correctly. Okay?
Okay.
And then check it anyway. Because you see, I'm capable of saying that we have a plus 1 here and then not writing it down, right? Not only capable, but prone to that sort of error. But you understand the process. We assume the solution, find out what the driving function must have been, and then check to see that the system transfer function is what we think it ought to be.
Do we need the s's over there like we had over here, s squared plus s?
The s's.
Yeah.
Well, you got to get s's when you do the Laplace transfer.
Right, okay.
Okay, and, oh yeah, okay. It's not a plus b plus c, it's s squared plus s plus 1. It's as squared plus bs plus 1.
Right.
I lost my bs again. Okay?
Okay.
So, you know,
Right.
Okay?
Okay.
Bottom line, if you assume an x function, you get your driving function, whatever the equation is. Do this, and you recover essentially a characteristic equation down here.
Okay.
And that's your system transfer function. And then if you drive it with something different, okay, you can transform your driving function. And then you can get the Laplace transform of your x of t function. Well, we'll get there next time.